do it.
Woo! Here we go. Alright, this one's in tens. Does that say square root of 7 or square root of 2?
7.
7.
11. Ooh.
Nasty. Alright. This one's going to be a fun one.
No.
When I say fun, I mean fun.
Emotionally draining.
Right? Okay. Let's look at this guy. Alright, so I kind of want to look at the 45 first because that's where our number is, right? So I got to draw something that's similar to this. So the first thing I'm going to draw is one that looks like it. And since this goes up, I'm going to draw it right here. And I have a thing right over here. It says if this is 45, 90, right? Then this is beta and beta. So this means this is beta and this is beta. And this is beta square root of 2. Okay?
So all we would have to worry or remember is it's across from 90? Or is it all
Yeah, it's across from 90 is beta square root 2. The other two, it's half a square. Is what you 45 is half a square. Okay? Question?
Why are you using beta instead of alpha?
Well, because they could be different. In this case, they're not going to be different. They're going to actually be the same. Alpha is going to equal beta. But that's not always the case. Okay? So alpha could, this could have been set up like this. Whereas instead of the 60 degree right here, this could have been the 30 degree. Right? The 60 degree could have been like that. And that would have been different. Right?
Is beta just...
Then this is alpha, and this is beta, and those are going to be two different things. Does that make sense? In this case, this beta is going to equal this alpha, but you don't know that yet. I do, but you guys don't, so that's why I use two different ones. Good question.
Well, you just told us.
Yeah, well, life goes on. Alright, so now I got to figure out what is beta, and the reason is x is up here. And I know that I have a triangle shape that looks like that, right? Where I have a 60, and I have a 90, and I have a 30.
What's this called again?
Right? And then I have, remember, across from the 30 is alpha. Okay? And across from the 60 is alpha square root 3. And across from the 90 is 2 alpha. And that's also going to be our x, right? And it's okay that we have alpha and we have beta. That's okay. That we have alpha right here as our length and beta right here as our length. That's okay. Alright? Because alpha and beta in this case are going to be what? In this case, they're going to be the same. So that's cool. And we'll use that. But first, we got to figure out what beta is. So what is beta? Right? Beta.
It's my dad.
It is It's 45. Oh.
Beta square root 2 is equal to what? 9 square root 7. Right?
Oh, yeah.
Beta square root 2 is equal to 9 square root 7. So to figure out what beta is, I need to do what? Now, first of all, what is the rule for that?
Special triangle.
Which one?
I don't know.
45, 90. So that's why we kind of, you don't have to put it, but it's, they might want to see that on the state test. But yeah, special triangles. Now, how do I get beta alone?
Divide.
Yeah. Square root of 2. Oops, not 3. 2. Now, here's the thing. we can't have square roots in the bottom. Okay? So there's two ways I teach this. One way is this. If I have something like this, then I'm going to take this up and leave a shadow down beneath. So I go, that means I'll have square root of 2 times the square root of 7 over 2. And the shadow is underneath. What I'm really doing there is I'm multiplying by the square root of 2 and the square root of 2, meaning 1, right? A factor of 1. And then these two, what's the square root of 4? It's just 2, right? So that's what's happening. But what goes on in here? What's 2 times 7? 14. So we get 9 square roots of 14 over 2. Okay? And so that's what happens is beta is equal to 9 square roots of 14 over 2. And that's our simplification. Now up here, we did the division property of equality though, right? So now we know what beta is. We already said alpha and beta are equal, but let's say it legitly now, right? So let's say that beta is equal to alpha. Or actually, let's do the other way. Let's go alpha is equal to beta. Why would I write it that way? Symmetrically. Yeah, because the symmetric property tells me I can write it either way, right? And if I write it that way, then I can use a transitive property, which is if A equals B and B equals C, or in this case, if B equals C and A equals B, then A will equal C, right?
The next step is simple.
So, little different, but it's still transitive, right? So, transitive property, now this is what? What told us this? Not special triangles. In this case, reflexive, right? They're the same line, they're the same segment, right? So, reflexive property. They mirror each other. They're exactly the same. Okay? So, they share the same line, right? So, AB is equal to AB.
Is that
That's
by 3?
That's what's going on there. Okay? So, that means alpha equals beta. And then we're going to go, well, did we say that we wanted beta? Oh, we did beta. So that means we got
This is 2 weird.
alpha is equal to 9 square roots of 14 over 2, which is the transitive property. Okay? So we have the transitive property there. And then what? Well, we still need to know x, right? So what is x with respect to everything else?
2 alpha?
Yes, good job. X and 2 alpha are the same. So then I say 2 alpha is equal to x because of special triangles of 30, 60, 90, right? And then what is alpha again?
B or
9 square roots of 14 over 2, right? So then it's 2 over 1 times 9 square roots of 14 over 2 is equal to x. Substitution, right? And then look what cancels out. So x, 9 square roots of 14 is equal to x. And that is simplifying. Boom, number 8.
Okay, cool.
What's up, people? Bring it, bring it, bring it. All right, let's go. It's almost lunchtime. We got time. We can do 3 more problems.
Sure.
See?
No.
I like it. I like it a lot.
Did we even have to do this?
What?
Did we even have to do this part if it was gonna be the same right here?